Good morning. Today we will discuss about perpendicular lines and its properties. So what are perpendicular lines? If two lines intersect each other at 90 degree, if the intersection of two lines makes an angle of 90 degree, then those lines are known as perpendicular lines. What? The intersection of two lines makes an angle of 90 degree, then these two lines are called perpendicular lines. So when we consider perpendicular lines, we have a property related to perpendicular lines in coordinate geometry. Like we discussed about the property of parallel lines, as if two lines are parallel, they have the same gradients. If two lines are parallel, their gradients are equal. Similarly, if two lines are perpendicular, then the product of their slopes is minus 1. If two lines are perpendicular, then the product of their slopes is minus 1. That means if the gradient of a line is m1 and the gradient of its perpendicular line is m2, we have two lines. The first one has a gradient m1 and the second one has a gradient m2. If these two lines are perpendicular, then product of the gradients is minus 1. That means if two lines are perpendicular, then product of their gradients, that means m1 multiplied by m2 is minus 1. This is the property of perpendicular lines. So remember, if two lines are parallel, then their gradients are equal, and if two lines are perpendicular, then product of their gradients is minus 1. So remember these two concepts. Okay, now let's do one example question. A line is perpendicular to y is equal to x by 5 plus 3, passes through 1 3. What is the equation of the line? So what do you understand from this question? Yes, there is a line which is perpendicular to another line, y is equal to x by 5 plus 3. So there is a required line, and that required line is perpendicular to another line, y equals x by 5 plus 3. That means in this question there is a required line and a given line. So which is a given line here? Yes, y equals x by 5 plus 3. So a line is given which is y equals x by 5 plus 3, and our required line is perpendicular to this line. Our required line, let it be L, it is perpendicular to the given line. That is one condition. And the second condition is this required line passes through the point 1 3. So how many conditions are given here? Yes, there are two conditions given. One is the required line is perpendicular to the given line, and the second condition is the required line passes through the point 1 3. Okay, so when you deal with a question like this, the condition of perpendicularity. When you find a condition perpendicular, there you have to remember the concept m1 into m2 is equal to -1. It's nothing but product of the gradients is -1. So wherever you find two lines are perpendicular, so suddenly remember the concept product of the gradients is -1. So as the line is perpendicular to y equals x by 5 plus 3, this is the first condition given. You can say gradients are equal. Are the gradients equal? As the line is perpendicular to y equals x by 5 plus 3, we can say the product of the gradients is -1, isn't it? Okay, now let us find the gradient of y is equal to x by 5 plus 3. When you take y equals x by 5 plus 3, it can be rewritten as y is equal to 1 by 5x plus 3. X by 5 can be written as 1 by 5x plus 3. And this equation looks like y equals mx plus c. Isn't it? This is the equation of line what we learned in grade 9. So when you compare these two equations, m is the coefficient of x, and in our problem that is 1 by 5. So what is the gradient of this line? It's nothing but 1 by 5. So we can say that one as m1. Therefore m1 is 1 by 5. That means let us consider m1 as the gradient of given line. Our given line is y is equal to x by 5 plus 3, which is y is equal to 1 by 5 x plus 3. X by 5 can be written as 1 by 5 x plus 3. Here the coefficient of x is 1 by 5, which is the form of y is equal to mx plus c. So we can conclude m is equal to 1 by 5. So in our formula we can say m1 is equal to 1 by 5. So now we can use the product of the gradients is -1. That means m1 into m2 is equal to -1. That implies, m1 is 1 by 5 times m2 is equal to -1. So when you cross multiply this 1 by 5 here, we get m2 is -1 into 5. When you cross multiply 1 by 5 here, we get -1 into 5, which is -5. So we get m2 as -5, which is the gradient of required line. So what is the gradient of given line? Is m1, that's equal to 1 by 5, and the gradient of the required line is m2, that is equal to -5. Okay, so we can find the equation of required line. Equation of line, as you know, equation of a line is y equals mx plus c. That implies y equals, m stands for gradient of the line. We found gradient of the line as -5. Whether it is m, m1 or m2, you don't bother about that. So m2 stands for gradient, that is same as m here. So it become minus 5x plus c. But we do not know what is the value of c. So to find the value of c, this point is given here. Which point the line passes through? 1, 3. So at 1, 3, the point 1, 3, that means x is 1 and y is 3. We get 3 equals minus 5 times 1 plus c. That is minus 5 times 1 is minus 5. When it goes this side, we get 3 plus 5 is equal to c. Or we get c is equal to 8. So now we can find the final equation of line. Therefore, equation of line is y equals minus 5x plus c. As c is 8, we get minus 5x plus 8. Okay, let's do a few more problems, then only we'll come to know in detail about this. So remember, using this perpendicularity, we can find the gradient of the required line, and using this point we can find the intercept c. Okay, question number 2. Given a 0 0 and b 1 3, find the equation of the line perpendicular to AB with a y-intercept 5. So when you read this question, here also you can find two lines. One line is a line formed with the points A and B. That means given a point A0 0, this is A0 0, and another point is B1 3. B1 3. So when you consider this question, there are two lines. One line is line AB, which is formed with A0 0 and B1 3. So with A and B, there is a line. AB is a line. And now we have another line, which is our required line. And given that the required line is perpendicular to AB, so we have another line. This is the required line and it is perpendicular to AB. Got the concept? With a y-intercept of 5. Okay, so here two informations are provided about our required line. What are the two informations provided about required line? Yes, the first one is perpendicular. So from what for this perpendicularity mentioned here? The perpendicularity is mentioned to find the gradient of the required line. As you know, if the gradient of AB is m1, gradient of AB is m1 and the gradient of required line is m2, then we get product of the gradients m1 into m2 is equal to minus 1. With the help of this concept, you can find the gradient of required line, isn't it? So for that, perpendicularity is given. So clearly you have to understand that. And the second information provided is y-intercept, that is c. So in this question, c is given directly. So we no need to do an extra step like previous problem. So here only the step what we required is to find the gradient of the required line. Okay. For that, let us find the gradient of given line. That is our first work. Find the gradient of the given line. That means gradient of AB. So gradient of AB, let's mention that as m1, which is equal to the change of y by an increase in x, isn't it? The formula is y2 minus y1 divided by x2 minus x1. So here this is x1, y1, x2, y2. So when you substitute in the formula, we get y2 minus y1, that is 3 minus 0, by x2 minus x1 as 1 minus 0, which is equal to 3. So 3 is the gradient of AB, which is m1. Okay, now as the line is perpendicular to AB, the concept. See, yesterday we discussed the same question with parallel. As the line is parallel to AB, same question we discussed yesterday. In that problem, as the line and AB were parallel, their gradients are equal. So the gradient of AB is 3, which is same as the gradient of required line when they are parallel. But as they are perpendicular here, we get m1 into m2 is equal to minus 1, where m1 is 3. So we get 3 times m2 is minus 1. Or when you transpose 3 to right hand side, we get m2 as minus 1 divided by 3, which is the gradient of the required line. So what is the gradient of the required line? Minus 1 by 3. And what is the y-intercept of the required line? It is 5. That means m is minus 1 by 3 and c is 5. Now let's find the equation of the required line. So for our required line, gradient is minus 1 by 3 and c is 5. Therefore, equation of line is y equals mx plus c, which gives us the result y equals minus 1 by 3x plus 5, which is the equation of the required line. So when you find this question, find the equation of the line perpendicular to 2x minus y minus 1 is equal to 0 and passing through 2 minus 1 by 2. So in this question also, two concepts are given about our required line. One is required line is perpendicular to 2x minus y minus 1 is equal to 0 and passing through another point. So when you consider this perpendicularity, it is for finding the gradient of required line, because as they are perpendicular, we get m1 into m2 is equal to minus 1. This is a plan we have to make when you read a question like this. And the line passing through a point, or required line passing through a point, this is given to find the y-intercept. So using perpendicularity, we get the gradient of the line, and using this point, we get y-intercept. So that we can use the equation of the line as y equals mx plus c. Okay, so let us find the gradient of the required line. For that, we require the gradient of the given line, which is a given line here, this one. So let's write the given line. 2x minus y minus 1 equals 0. Now this line is mentioned in the form of an equation. Okay, So our given line can be given in different format. Like this is given as an equation. In the previous question, they give 2 points of the given line. Isn't it? The previous question, there were 2 points on the given line, which was A00 and B13. So if 2 points are given, there we can find the gradient using the formula y2 minus y1 by x2 minus x1. And if the given line is given in the form of an equation, our task is to change it in the form of y equals mx plus c. Change it as y equals mx plus c, so that coefficient of x will be the gradient. So here, as it is mentioned as an equation, change it into the form of y is equal to mx plus c. So for that, our task is very simple. You see here minus y. If you transpose minus y to right side, we get 2x minus 1 is equal to 0 plus y, which is y, or y is equal to 2x minus 1 in the form of y equals mx plus c. Very simple. So compare this one. The gradient is 2, coefficient of x. So gradient of the line, we can name it as m1 for our convenience. That is 2. Okay. Gradient is 2. Now let's find the gradient of required line. As the line is perpendicular to 2x minus y minus 1 equals 0, we get the concept m1 into m2 is equal to minus 1. That implies m1, you know already m1 as 2 times m2 is equal to minus 1, which gives us the result as m2 is equal to, what is m2? Gradient of required line. That's equal to, transpose 2 to right side, we get minus 1 divided by 2. So this is the gradient of required line. So we got the gradient of required line. Now we want C. Let's find C now. So as the gradient of the required line is minus 1 by 2, let's write the equation of line. Equation of required line as y equals mx plus c. Always this is the equation, okay, we use in IGCSE classes. So we get y equals minus 1 by 2x plus c. Because m is minus 1 by 2, m stands for gradient of required line, that we found as minus 1 by 2. So y is equal to minus 1 by 2 x plus c. Now to find the value of c, we make use of this one. Okay, so at 2 minus 1 by 2, that means x is 2 and y is minus 1 by 2, we get minus 1 by 2 is equal to, here we have minus 1 by 2 times x. As you know, x is 2, replace x as 2 plus c. This 2 and 2 get cancelled. So we get minus 1 by 2 is equal to minus 1 plus c. Take minus 1 to left side. We get it as plus 1. That is 1 minus half is equal to c. Or we get c as 1 minus half is how much? Half. So what is the value of c now? 1 by 2. Therefore, equation of required line is y equals, already we got this much, the equation, minus 1 by 2x plus c as 1 by 2. We can consider that one as the equation of required line. Still we can simplify it, but if you don't simplify also, we get the answer. Let's see how to simplify it and write. Okay. For that, work is very simple. You see here, in right hand side, it is y equals minus 1 by 2. That means minus x by 2 plus 1 by 2. Common denominator. So we can take it as LCM, which is minus x plus 1. Now cross multiply this 2 here. So we get 2y equals minus x plus 1. Or if you take all the terms to this side, we get 2y plus x minus 1 is equal to 0 as result. Okay. Okay. Let's discuss one more question, which is show that a minus 3 6, b minus 12 4, c 8 minus 5 could not be the vertices of a rectangle. So we have to verify whether the figure formed is a rectangle. Okay, let's draw the diagram. So here we have to show that it should not be the vertices. These points are not the vertices of a rectangle. That means we have to show that the figure formed is not a rectangle. For that, you know what makes a quadrilateral as a rectangle? What makes a quadrilateral as a rectangle? It's very simple. All the four angles are 90 degree each. That means this angle is 90 degree, this is 90 degree, it's 90 degree, this is also 90 degree. So if we show this angle is not 90 degree, if we show this angle is not 90 degree, this angle is suppose not 90 degree. That means if these two sides are not perpendicular, because in a rectangle all the sides are adjacent sides are perpendicular to each other. If we show this is not perpendicular, it won't be a rectangle now, isn't it? So how do we show it is not perpendicular? It's very simple. Find the gradients and find the product of the gradients. We know if the product of the gradients is minus 1, if m1 into m2 is minus 1, then the lines are perpendicular. If it is not minus 1, then the lines are not perpendicular. So let's find the gradient of AB and BC separately. So let's find the gradient of AB. As you know, A is minus 3 6, B is minus 12 4. The gradient of AB. Let's make that one as M1, which is y2 minus y1 by x2 minus x1, because remember 2 points are given. Gradient is this. We get it as this is x1, y1, x2, y2. So we get 4 minus 6 by x2 minus x1, minus 12 minus minus 3. That is 4 minus 6 is minus 2 by minus 12 plus 3. Minus into minus. We get it as minus 12 minus 2 divided by minus 12 plus 3 is how much? Minus 9, which is 2 by 9. So we get M1 as 2 by 9. Now let's find M2, which is the gradient of BC. So gradient of BC, which is M2, is y2 minus y1 by x2 minus x1. So this is x1, y1, x2, y2. So we get it as minus 5 minus y1, 4, by x2 minus x1. It is 8 minus x1 is minus 12. So minus 5 minus 4 is minus 9 divided by 8. Minus into minus is plus. That is 8 plus 12, which is 20. This is M2. And we got M1 as 2 by 9. So here our concept is we need to check whether AB is perpendicular to BC. We have to check whether AB and BC are perpendicular. If AB and BC are perpendicular, then the figure formed is a rectangle. Okay, so to check that perpendicularity, let us multiply M1 and M2. Because remember the concept, if two lines are perpendicular, then M1 into M2 is equal to minus 1. So let's multiply M1 and M2. Which is 2 by 9 times minus 9 by 20. That's equal to, when you cancel the terms, we get it as minus 1 over 10. Because 9 get cancelled. 2 ones, 2 tens. We get M1 into M2 is minus 1 over 10, which is not equal to minus 1. So what is the concept we get here? M1 into M2 is not minus 1. Did you get the concept? So as M1 into M2 is not minus 1, we can say AB is not perpendicular to BC. As AB and BC are not perpendicular, we can conclude that the figure formed is not a rectangle. Okay.